All right, for number 3, again, in order to get a graph, we're going to have to solve this one for y. And to get rid of this exponent here, we're going to have to raise it to the reciprocal. Because when we have an exponent raised to an exponent, we multiply those, and that's just going to give us y. Now, the thing we need to remember for this one, when we raise this to 3/2, really what we're doing two things at once. We're cubing it, and we're taking the square root. What do we normally do if we take the square root of both sides? We need to remember positive or negative x to the 3/2. It's just like if we were to just take the square root of both sides, we need positive or negative. Raising it to the 1/2, same thing. So we're going to have two equations that represent this curve. This is just a line. We get y equals x minus 2, and then the horizontal line y equals 8. So we can put those in our calculator. Again, make sure you have a positive x to the 3/2 and a negative x to the 3/2. Make sure you have parentheses around the 3/2 for the exponent part. If we graph all of these, we get this region right here that needs to be shaded in. So our region for this one is right here. We have a little bit below the x-axis there. So I'm going to sketch a graph of our shaded region. And now with all problems, we want to look at, is it a dx cut or a dy cut? So we need to figure out, is there one curve that's always above the other one, or is there one curve that's always to the right of another one? Here we've got 3 different equations, but if we look vertically, we can't do it because this graph is above itself right here, then it's above the line, and then this horizontal line's above it, so that we don't have one graph that's above the other ones the whole time. But horizontally, this line is always to the right of this curve, so we can do a dy cut here. So that means everything's going to be in terms of y. And actually part of it's already done for us here. Y equals 8. That is going to be our upper bound for our integral. So we've got that part started. We know the line is our right function. But remember, we need this solved for x. So we need it solved for x so that it's in terms of y. So x equals, we solve this for x, we get y plus 2. So that's our right function, the line. Then our left function is already solved for x. X equals y to the 2/3. So we're going to have y plus 2 minus y to the 2/3 dy. Only thing we're missing here is our lower bound. So we could do that by setting these equal to each other and solving, but for this one, let's just do it using the calculator. So we go to second trace. We want to calculate the intersection, so that's 5. And we want to make sure we're on the right curve here. Remember, this is one equation. The bottom part's a different one. So I actually have to jump down to this bottom one and hit enter. And the line, enter, that's where we're trying to find the intersection. Guess? Yes. So our intersection's at 1, -1. Remember, we're talking y values here, so our -1 is what we're interested in here. That's our lower bound. So now we can go ahead and put this in the calculator. So that's math 9. We're going to put that whole function in. Even though this is in terms of y, we can just do it in terms of x in our calculator. It doesn't make a difference. Remember that the parentheses around the exponent. So that's our function, comma x, comma our lower limit, so -1, comma upper limit 8. Sometimes it takes a little while. But whenever we do this, you always want to try and make sure that you give answer as a fraction if possible. So once you get this decimal answer, you want to see if it can be converted into a fraction. For this one, if we go to math fraction doesn't work. So we're just going to round this one and end up getting 29.7 approximately.